that programmers make characteristic errors. That is, one person usually makes some types of mistakes, and another person makes other types of mistakes. By tracking their own mistakes, programmers could learn to recognize their characteristic errors. Once they did, they'd stop making them. Watts suggested to me that we should think of non-reproducible bugs as tester mistakes, the same way as we've got programmer mistakes. If a non-reproducible bug reflects a blind spot in your thinking, and if you can learn what the critical condition would have been to replicate a bug that you couldn't replicate, you can track that. Eventually, this can give you a sense of what conditions you've been missing that tend to be relevant to this company on this platform. So the next several slides give examples of conditions that colleagues and I have missed in our testing that turned out to be critical for some bugs. This list is way out of date. It'll miss many of the conditions that are probably relevant to you in your application on your platform, but perhaps it'll give you some ideas when you're trying to make a bug reproducible. If you find this useful as a starting list of ideas, I strongly suggest that you make one of your own. When a programmer fixes a bug, ask her how you could have triggered that bug in the build of the software you tested. And then try it. Bring up that build and try to reproduce the bug now. If you can, you now understand what the critical condition was that you missed. Write it down. Keep track of how often you miss that condition in the future. If it's a significant condition, eventually you're going to stop missing it. There's a long list of examples. You can go through most of them on your own. I'll give one example to give you a feel for the list. The example is the delayed effect bug. What distinguishes a delayed effect bug is that the failure happens, but you don't notice it. Later, maybe hours or days later, there's a more visible consequence of that failure, and that's what you notice. Here's a simple example of a delayed effect bug. A memory leak. Suppose you test a paint program. When you draw a circle, the program uses memory. When you erase the circle, maybe the program is supposed to release that memory back to the operating system. If it doesn't, you have a memory leak. If you draw a circle, erase the circle, draw the circle, erase the circle, draw the circle, erase the circle, every time you draw the circle, the program uses more memory. Eventually, you're going to run out of memory, even though you've only got one circle on the screen. Imagine running a sequence of tests where you do lots of circle-related testing. You try different size circles and different colors and different fills. You don't see any bugs, so eventually you say, okay, I'm done with circles. Now it's time to test something else. So you put a text box on the screen, and it crashes immediately with an out-of-memory error. Well, your first intuition might be that text boxes are really badly broken. But as you test and retest on text boxes, you're not going to find anything. What you have to do is to think backwards in time. What was I doing before I was working with text boxes? Then you'll go, oh, it was a long sequence with circles. And that's where you find the memory leak. So the rest of these slides list more ideas. I'm not going to describe all the ideas one by one. You can read them yourself. Here's another set. On we go. Here's another set. 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 So you go through all your ideas, and you still can't make the bug reproducible. When should you close it as just no one can reproduce this bug? We're done with it. Non-reproducible bugs are hard to troubleshoot, but it's often much easier to troubleshoot them when there are multiple reports of the same failure, because each report offers different information. Because of this, many development groups keep all of their non-reproducible bugs open in the bug tracking system. Now, this causes a problem at some companies because they have managers who really rely on bug statistics, like how many bugs are open. They want to compute how long it takes on average before their programmers fix a bug. And if you keep the non-reproducible bugs open, it inflates the open bug count, and it really hurts the statistics on programmer productivity. So that at companies that rely heavily on these statistics, there is enormous pressure to close non-reproducible bugs right away. But that means a lot of hard-to-reproduce bugs that could have been fixed won't be fixed because we don't have these useful multiple reports open to see. I used to try to argue with managers and executives and especially independent quality assurance groups that relying on bug counts wasn't necessarily the most useful thing to do. I've given up on that. Instead, I've added a new resolution to bug tracking systems that I work with. In the typical bug tracking system, a bug status is open or closed. Closed bugs you never look at again, they're history. The resolution indicates what happened to the bug, like fixed or deferred. In companies that rely on bug statistics, I close non-reproducible bugs, but I assign them a resolution code that I call dumpster. This keeps the open bug count as low as if I had permanently closed, thrown away the non-reproducible bugs. But if I search for resolution codes of dumpster, I can easily find all of the closed, not reproducible bugs. The reason that I do this is that it makes it easy to go dumpster diving. Every week, imagine a tester and a programmer searching the database for dumpster bugs. What they're looking for is similarities. If they find a lot of reports that seem to be about basically the same bug, they can isolate those. They can say, let's work on these 10 failures this week. If they find the underlying problem from all of these different angles on what this problem looks like, then the bug can get fixed or deferred or whatever, and the resolution, of course, gets updated appropriately. If they still can't reproduce the bug, they can add their troubleshooting notes to one of the reports, and then they can leave these reports in the dumpster. They can try again much later. Keeping all the reports of similar failures makes handling of non-reproducible bugs more efficient and more effective. Hiding them in the dumpster keeps the bureaucrats happy because it lets their numbers look good. Of course, some bureaucrats would get very grumpy if you ever explained the dumpster system to them, because what you're really doing is keeping some closed bugs open. They would interpret that as manipulating their numbers, which of course is exactly what you're doing. You're working around their system in order to keep reports available that would otherwise be closed and discarded. Sometimes it's better to do the right thing than it is to tell people what you're doing. Let's review today's work. Our goal is to write reports well enough to make sure that the bug deferrals and bug rejections are based on the bug, not on the quality of the reporting. Failures that are genuinely non-reproducible can't be fixed. If you can't find the problem, you can't create a solution. But most failures are not genuinely non-reproducible, they're just hard. They could be reproduced if we only knew what the critical conditions were. But unfortunately, nobody can pay attention to all of the possible conditions, all of the possible outcomes of any test. So sometimes a failure happens under circumstances that we basically didn't notice. There are lots of tools that can help capture this information. In my opinion, these are cheaper and probably more effective than writing out and following detailed test scripts. Keeping track of the critical conditions that you missed will help you imagine conditions that are interestingly relevant next time. Final point. There's a lot of value in writing a hard-to-reproduce bug up every time you see it. Make sure you include enough detail to make your report worth reading. Cross-reference your reports in a way that makes it clear that your goal is providing data, not padding the number of bugs reporting statistics. In companies that really worry about bug statistics, you might deal with the second and later reports of a hard-to-reproduce bug by making them comments on the initial report. This will keep the bug count down. But you're going to have to pay extra attention to writing in all the potentially relevant conditions that are automatically captured, like configuration information, if you were entering a full bug report.